Part 1. There are moments in astronomy when the sky itself seems to whisper that something has changed. Moments when data ceases to be numbers and becomes an event, a revelation. A moment that stretches the imagination and reminds us that we are not just studying the universe but are part of its unfolding. This story begins at the edge of our solar system, in the quiet and forgotten darkness beyond Neptune, where the sun is only a pale lantern, and where the cold is so deep that light itself seems to slow. It was there, on the 12th day of September, in the year 2025, that something impossible appeared. At first it was just a flicker, a violent flare in the ultraviolet spectrum, so bright and so sudden that it overwhelmed the sensors of SOHO, the Solar and Heliospheric Observatory. To the technicians at Mission Control, it looked like a glitch, the kind of false signal that comes from cosmic rays or magnetic interference. They logged it, filed it, and moved on. But 2 days later, half a world away, an amateur astronomer named Daniel Reeves, observing from the clear southern skies of Western Australia, turned his telescope toward the region and saw something that would shake the foundations of our understanding. Through his eyepiece, he saw a body glowing not with the dull, reflected light of ice, but with an internal brilliance. It shimmered like a living star, a core of radiance surrounded by a tail that stretched wider than 5 full moons laid end to end. The human eye is not easily fooled, yet even through the lens he could sense that this light was different, deliberate, as if the object itself were aware of being observed. He recorded the coordinates, checked for known comets or asteroids, and found nothing. What he had seen was new. The observatories confirmed it within hours. NASA, ESA, and multiple independent facilities catalogued it under a temporary designation, C divided by 2025 R2 Swan. But this was no ordinary comet. From its first moments of observation, it behaved like nothing in the catalogue of celestial bodies. Its albedo, the measure of its reflectivity, was not merely high. It was mathematically impossible. No natural substance, not ice, not rock, not even polished metal, could account for the intensity of its luminosity. Swan R2, as it was now called, was a paradox wrapped in light. Imagine standing on the frozen plains of Neptune's orbit, in the long shadow where the sun is reduced to a coin-sized spark, and then, suddenly, from the direction of Aquarius, another dawn rises. Blue-white, piercing, beautiful, as if a second sun were blooming at the edge of everything we know. For a brief instant, even the instruments designed to measure brightness faltered. The cosmos itself seemed to pause, holding its breath as this intruder crossed the boundary of our system. For centuries, comets have been the messengers of mystery, the travelers from the outer dark who remind us of how small and brief our lives truly are. They come and they go, leaving behind no trace except a memory of light. But Swan R2 defied that pattern. It moved with purpose, not with the chaotic drift of debris, but with precision. Its ultraviolet emissions pulsed in rhythmic intervals, not random, not natural, but structured, as though following an unseen sequence. Within days, the scientific community was split. Some called it a new class of comet, an interstellar wanderer unlike any before. Others whispered something far more extraordinary, that perhaps it was not a natural visitor at all. But what does it mean for an object to move with intention? To shine with a brilliance that no material can produce? To pulse with a rhythm that echoes through the electromagnetic field like a coded heartbeat? We have always looked to the stars for meaning. Yet, when something looks back, even in silence, the entire balance of curiosity and fear shifts. The data from SOHO, the Hubble, and the ground-based Keck Observatory began to align, pointing to one undeniable truth. Swan R2 was different. It was brighter than any interstellar object ever recorded, 100 times more luminous than the legendary Oumuamua, and it moved in a trajectory that ignored our laws of celestial mechanics. It was not merely passing through, it was entering. And as the days passed, a pattern began to emerge. A connection between Swan R2 and another object observed months earlier, a faint, fast-moving body known as 3I Atlas. Two trajectories from opposite ends of the galaxy, converging on the same star within the same month. Statistically, that is not improbable. It is impossible. The universe does not choreograph coincidence on this scale. By the time October arrived, every major observatory on Earth had turned its gaze toward the silent light, now drifting inward past Neptune's orbit. And the question began to spread, not just among scientists, but among anyone who has ever looked up at the night sky and wondered, what exactly has entered our solar system? A frozen relic of the void or something designed to arrive? Because whatever Swan R2 is, it did not come quietly. It announced itself with a radiance that rivaled the stars. And behind that light, there was something more, something structured, mathematical, deliberate. The kind of precision that nature rarely allows. Something enormous has entered our solar system, and as we watch it draw nearer, shimmering with the light of its own making, one truth begins to surface. This may not be a discovery at all. It may be a rendezvous. Part 2. When the first composite images of Swan R2 reached the data centers at the Jet Propulsion Laboratory, the analysts stared in disbelief. The object's luminosity was off the scale. Its core radiated in the ultraviolet and near-infrared bands simultaneously, creating a signature unlike anything ever seen before. Comets reflect sunlight, asteroids absorb it and re-emit faint thermal radiation. Swan R2, however, emitted coherent energy. It was producing light, not reflecting it. This was the first clue that it might not be a natural body at all. Within hours, every major observatory on Earth and in orbit trained its sensors toward the coordinates just beyond Neptune. The Hubble Space Telescope, the James Webb, the Chandra X-ray Observatory, and even ground-based radio arrays such as ALMA and FAST began collecting data. The findings were astonishing. Swan R2's spectrum displayed emission lines characteristic of ionized nickel and cobalt, materials common in manufactured alloys, but almost unknown in such concentration in natural celestial objects. Even more puzzling was the coherence of its reflected spectrum. The wavelengths were not chaotic, but quantized in discrete intervals. In laboratory terms, it looked engineered. At first, scientists at NASA and ESA hesitated to make public statements. The official position was cautious. Swan R2 was classified as a hyperactive interstellar comet, possibly with metallic inclusions. But inside the closed meetings of the International Astronomical Union, the tone was very different. The object's albedo, measured at 147, was physically impossible. No known surface, not even a polished mirror, could achieve that under the conditions of deep space. Something was amplifying the incoming light, re-emitting it with a gain factor greater than unity. That meant one thing: an external energy source. As days passed, more data poured in. Instruments aboard the Parker Solar Probe detected fluctuations in the solar wind, corresponding precisely to Swan R2's position. It was bending the heliospheric particles around itself, creating a magnetic cavity tens of thousands of kilometers wide. Normally, comets lose material when bombarded by the solar wind. Swan R2 deflected it, creating a void. The amount of energy required to maintain that field exceeded 10,000 gigawatts per second, greater than the combined power output of every energy facility on Earth multiplied several times over. Whatever this object was, it possessed an energy field strong enough to reshape the solar environment itself. The plasma readings showed another anomaly. At irregular intervals, the ultraviolet emissions from Swan R2 pulsed with exquisite precision. 22 beats every 24 seconds. Each pulse was identical in amplitude and frequency, as if the object were maintaining an internal rhythm. The data from SOHO, corroborated by the Deep Space Network, showed that these pulses slightly altered the local magnetic field. The phenomenon could not be explained by natural resonance or outgassing. It was coordinated. Some researchers began calling it the heartbeat. In Geneva, at the European Space Operations Center, a team led by astrophysicist Dr. Leanne Moreau conducted orbital modeling using data from multiple observatories. The simulation froze the room into silence. Swan R2 was not following a hyperbolic escape trajectory, as every known interstellar object does. Its path formed a closed, perfect ellipse, an orbit bound to the Sun. According to calculations, the orbital period was 22,554 years, with a precision margin of less than 1 second. Such stability across millennia was impossible without active correction. Gravity alone could not account for it. Moreau's team ran thousands of iterations, altering parameters for solar perturbations, planetary interactions, and galactic drift. Every time, the result was the same. The orbit was self-correcting, a feedback system adjusting velocity in micro-increments. In engineering, such self-stabilizing motion is the hallmark of active guidance. Something within Swan R2 was regulating its path with unimaginable precision. Meanwhile, the infrared data from the James Webb Telescope revealed that the object's outer layer radiated at an exact temperature of 273 kelvins, the freezing point of water. No natural body in space maintains such equilibrium without fluctuation. The temperature remained constant regardless of distance from the Sun, suggesting internal thermal regulation. The most plausible conclusion, if one dared to voice it, was that Swan R2 was managing its own heat. In the astrophysical journals, speculation began to circulate in veiled language. Terms like non-natural morphology and anomalous thermodynamics appeared in preprints. But behind closed doors, the conversation was bolder. Some scientists were convinced Swan R2 was artificial. They debated its possible function. Was it a probe, a vessel, a beacon, or perhaps something beyond our current categories of technology? In Pasadena, the Jet Propulsion Laboratory compared Swan R2's telemetry with historical data from earlier interstellar visitors, such as Oumuamua in 2017 and Borisov in 2019. The pattern was clear. Those objects had entered and exited the solar system on open trajectories, moving too fast to be captured by gravity. Swan R2, by contrast, had slowed down. Its deceleration curve suggested controlled braking, a gradual reduction of velocity inconsistent with any known natural process. It was as if the object had applied thrust. Thrust in astrophysical terms means propulsion. A comet cannot propel itself. But when the data was filtered for spectral shifts, researchers found emissions in the microwave range consistent with ionized xenon, the very element used in ion thrusters aboard human spacecraft. The readings were faint, but real. Something inside Swan R2 was producing periodic bursts of ionized gas in the precise ratio required for vector adjustment. The idea that this was coincidence quickly collapsed. On the 20th of September, an emergency symposium was convened under the coordination of the International Astronomical Union. Representatives from NASA, ESA, JAXA, Roscosmos, and CNSA attended in private. For the first time, a consensus began to form that Swan R2 might not be a natural object. The term artifact appeared in the meeting transcript, cautiously but unmistakably. One participant, Dr. Miguel Andrade of the University of São Paulo, stated plainly that the object exhibited intentional energy modulation indicative of a designed system. His words were met with silence, but no one contradicted him. As the object approached the orbit of Uranus, its brightness increased exponentially. Optical telescopes could no longer observe it without specialized filters. The energy output grew by a factor of 10 every week, yet the object's surface temperature remained unchanged. This implied an internal mechanism capable of dispersing vast energy without overheating, a feat far beyond current human engineering. Then came the first transmission anomaly. On the 24th of September, the Deep Space Network Station in Canberra detected a repeating electromagnetic signal originating from Swan R2's direction. It was not a random burst, nor a solar reflection. The signal consisted of 22 discrete pulses spaced precisely 1.2 seconds apart, identical to the ultraviolet rhythm observed earlier. When the data was plotted into binary form, it produced ratios matching the object's own orbital parameters, its period, eccentricity, and inclination. The message, it seemed, was a description of itself. A cosmic self-introduction. At the SETI Institute, researchers attempted to decode the signal further. After filtering out noise and converting the binary pattern into spectral harmonics, they discovered that the sequence contained repeating mathematical constants, pi, the golden ratio, and the speed of light expressed in base 2 notation. These were universal markers, the kind any intelligent civilization might use to indicate comprehension of mathematics and physics. The realization was chilling. Swan R2 was not only transmitting, it was communicating in a language that transcended species. Even more extraordinary was what followed. Hours after the initial detection, similar signals began to echo faintly through the heliosphere. They were reflections, synchronized precisely with the original source, as though bouncing between Swan R2 and an unseen companion. When analysts traced the timing, they discovered the reflections corresponded to the position of 3I Atlas, the smaller interstellar body that had entered the solar system months earlier. The implication was inescapable. The two objects were interacting. For decades, astrophysicists have studied binary systems. Twin stars, twin asteroids, twin pulsars locked in gravitational dance. But this was something different. These were interstellar visitors from opposite directions, now synchronized by frequency and pulse count, both radiating in harmonic resonance. The odds of such alignment occurring naturally were infinitesimal. It suggested coordination, a dialogue conducted through the language of electromagnetism. In the laboratories of the European Southern Observatory, spectral analysis revealed that Swan R2's emissions contained a modulation pattern known as frequency hopping, a technique used in digital communication to prevent interference. The frequency shifts followed a Fibonacci sequence, a mathematical spiral found in biological growth and also in artificial encryption. It was as if Swan R2's signal was designed to be resilient, intelligent, adaptive. The question that consumed the scientific community was no longer whether the object was natural, but what its purpose might be. Some hypothesized that it was a probe, perhaps launched millions of years ago by a civilization long vanished, still functioning through automated systems. Others speculated it could be an archive, a kind of interstellar repository preserving information across epochs. The most daring suggested that it might be an active observer, recording the evolution of civilizations like ours. As data accumulated, patterns deepened. The rhythmic pulses from Swan R2 began to influence Earth's magnetosphere, subtly but measurably. Instruments in Finland, Chile, and Antarctica recorded microfluctuations synchronized to the 22-second waveform. The phenomenon spread through the ionosphere, forming what researchers called electromagnetic standing waves. Nature rarely produces such coherence. To some, it seemed like synchronization, as if Swan R2 were aligning itself with our planet's magnetic heartbeat. The media, still largely unaware of the full implications, reported it as a spectacular comet, brighter than any in recorded history. But within the scientific networks, a quiet urgency grew. If this object was artificial, its scale and energy capacity suggested technology thousands, perhaps millions, of years ahead of humanity. Yet amid the wonder, there was unease. By early October, Swan R2's path carried it within the orbit of Saturn. Observations showed its acceleration increasing rather than slowing. The ultraviolet pulses grew stronger, forming complex patterns of nested frequencies, modulation within modulation, almost like a carrier wave embedding secondary data. Some analysts believed it was transmitting a message, though none could decipher it. On the 10th of October, the Hubble captured something that defied explanation. As Swan R2 approached its perihelion, the point closest to the Sun, it emitted a vast plume of plasma that curved unnaturally against the solar wind. The jet did not disperse chaotically like cometary gas. It formed a coherent beam, focused and narrow, stretching millions of kilometers toward the Sun. For 22 seconds, that number again, the beam glowed, then vanished. Immediately afterward, every major observatory registered a single, synchronized electromagnetic pulse sweeping through the inner solar system. It was measured at 22 gigahertz, the same frequency used by human deep space communication arrays. Whether by coincidence or design, the match was exact. The signal passed through Earth's magnetosphere, leaving a faint echo that persisted for hours. What happened next deepened the mystery. Both Swan R2 and 3I Atlas began to fade from view, slipping behind the blinding glare of the Sun. Astronomers call this phase solar conjunction, a time when the Sun's light blocks direct observation of objects near its corona. Normally, this lasts only days and carries no particular meaning. But this time, something different occurred. 3 days before conjunction, instruments worldwide detected a sudden burst of electromagnetic radiation, 22 seconds long, perfectly symmetrical, coming from the direction of the Sun but lacking any solar characteristics. The waveform was structured, harmonic, and stable. In laboratories, scientists compared it to a synchronization signal, the kind used by spacecraft to align clocks before executing coordinated maneuvers. The implication was staggering. Swan R2 and 3I Atlas might be preparing to act together. Whether that meant a maneuver, a transmission, or something beyond comprehension, no one could say. For the first time in recorded history, humanity was witnessing what could be the deliberate operation of an interstellar system within our own solar neighborhood. And then, suddenly, silence. The two objects disappeared behind the Sun, leaving the instruments blind. No telescope, no satellite, not even the Parker probe could observe them. For the first time, we faced an event we could not watch, only infer. Scientists across the world could do nothing but wait for the objects to re-emerge, to see whether they would appear unchanged, or if their passage behind the Sun would mark the beginning of something new. In the darkness of uncertainty, speculation became both science and philosophy. Were we witnessing the arrival of a probe launched by a civilization far older than humanity, returning every 22 millennia to check on the progress of intelligent life? Or were we observing the automated remnants of a lost culture, still executing instructions written before Earth had cities, languages, or fire-lit myths? Swan R2 had already rewritten our understanding of celestial mechanics, energy dynamics, and communication. But more than that, it had forced us to confront a deeper truth, that perhaps the universe is not silent, only subtle, and that sometimes, when it speaks, it does so not in words, but in the language of numbers, light, and time. For now, the solar system holds its breath. Two luminous enigmas linger behind the Sun, hidden by its fury, perhaps waiting, perhaps watching. The instruments still hum with residual echoes, faint harmonics whispering through the radio spectrum. The rhythm of 22 repeating endlessly, like a heartbeat in the void. And in observatories across Earth, from Chile's deserts to Hawaii's peaks, scientists wait for the curtain to lift. They know that when Swan R2 reemerges, the universe may not look the same. Because when something enormous enters our solar system and moves with such quiet purpose, it does not merely pass through, it changes everything that watches it. Part 3. When the light of the sun finally loosened its grip and the veil of plasma thinned, the waiting ended. Observatories around the world, their instruments tuned to the faintest whisper of ultraviolet and radio frequencies, caught the first returning glimmers of Swan R2 as it emerged from conjunction. What they saw was not the same object that had vanished weeks before. The brightness had changed, not increased or diminished, but modulated, pulsing with a new pattern of 22 intervals repeating at precise harmonic spacing. The rhythm was slower now, deeper, almost like the echo of a mechanical breath. Across continents, scientists held their collective breath. The data streams showed that Swan R2 had altered its orbit ever so slightly, adjusting inclination by a fraction of a degree. A correction too delicate to attribute to natural gravitational forces. It was as if, during its invisibility behind the sun, the object had performed a maneuver, a recalibration, a deliberate act. The conclusion was unavoidable. Swan R2 was not drifting through our system by accident. It was maintaining itself, alive in a mechanical sense, sustained by a purpose we could not yet fathom. In the months that followed, attention turned to its composition and possible structure. The James Webb Telescope, observing in the mid-infrared, captured data suggesting a layered surface. The outer shell emitted consistent thermal radiation, while beneath it, deeper layers reflected signals in frequencies associated with high-density crystalline alloys, materials that do not exist naturally outside of controlled manufacturing processes. Simulations hinted at an internal lattice designed to distribute energy uniformly, perhaps to withstand the extremes of interstellar travel. Some analysts speculated that Swan R2 might not be solid at all, but a shell surrounding a core of energy, a reactor of unknown design feeding on magnetic flux from the solar wind. To understand what such an object could be, one must look back at the history of humanity's search for meaning in the stars. Every era of exploration has carried with it the belief that beyond the darkness lies discovery, that intelligence cannot be confined to a single world. The Voyager probes, launched in the 20th century, carried golden records engraved with sounds and symbols of our species, an offering to whatever intelligence might find them. Perhaps Swan R2 is the mirror of that gesture, an ancient vessel from another time, another civilization, moving through the cosmos on its own mission of remembrance. Dr. Leanne Moreau, whose team first identified the elliptical orbit, became the voice of this new era of wonder. In interviews, she spoke softly. Her words weighted with the gravity of what she knew. "We are witnessing an artifact of continuity," she said. Something that has existed longer than human civilization itself, returning to the same star, the same orbit over and over, for reasons that transcend our understanding. Whether it is machine, message, or monument, it represents endurance, a concept the universe honors more than any other. Her statement echoed across scientific forums, resonating not as speculation but as philosophy. Others looked to ancient history for parallels. Archaeologists revisited myths that spoke of returning lights, silver chariots, and the watchers in the heavens. From the stone circles of England to the desert lines of Nazca, they found alignments pointing toward the region of the sky where Swan R2 had once been visible in its previous orbit, roughly 22,000 years ago. Could these structures, built by hands that knew nothing of telescopes, have been inspired by the same spectacle we now observe through modern lenses? Were they perhaps unknowingly messages of acknowledgement sent back to whatever intelligence placed the object there? If Swan R2 is a probe, its creators may have sent it long before Earth bore the marks of human life. Imagine a civilization so old that our entire recorded history fits within a fraction of its attention span. To such beings, time itself might be the medium of communication. Each orbit could be a word, each reappearance a sentence written across cosmic epochs. What message could travel so slowly, so patiently, that it arrives not in centuries, but in ages? The answer may lie in the numbers that define its existence. The 22 pulses, the 22,000-year orbit, the 22 gigahertz frequency, all variations of a single constant, perhaps a universal key to unlock the concept of recurrence, of cycles, of return. There is a quiet poetry in this possibility. For if Swan R2 is indeed an engineered artifact, then somewhere, in the uncharted folds of our galaxy, there exists a civilization that understands patience not as waiting, but as continuity. Perhaps they set these objects adrift as markers, cosmic beacons meant to measure the passage of intelligent life. Each time one completes its orbit, it may record the electromagnetic footprint of every world it passes, the whispers of technology, the flicker of radio waves, the heartbeat of civilizations rising and falling. It is possible that when Swan R2 departs, it will carry with it the sum of everything we are, encoded in its own language of light and rhythm, returning the data to its creators on a timescale so vast that human lifetimes barely register as moments. Technically, the implications are staggering. A self-sustaining craft capable of surviving the vacuum for tens of millennia would require near-perfect mastery of energy and material science. Its propulsion, if indeed it uses one, operates without visible exhaust, implying manipulation of plasma fields or even direct interaction with the quantum vacuum. Some theorists propose that Swan R2 employs a magnetic monopole drive, bending space-time itself to alter trajectory. Others believe it generates miniature singularities, feeding on the energy released by their evaporation. The mathematics of such mechanisms exist in theory, buried deep within quantum electrodynamics, but no human engineering has ever approached their practical realization. If Swan R2 functions on these principles, then it is not merely a machine. It is a testament to physics we have only begun to imagine. But beyond the equations lies something more human. The sight of that glowing arc crossing the sky above Neptune's orbit, visible even to small telescopes, has ignited a fire in the collective imagination of our species. For the first time since the dawn of the space age, the boundary between myth and science has blurred again. Children ask if it is alive. Poets write of a second dawn. Scientists, cautious by nature, find themselves speaking of beauty, of intention, of wonder. The discovery has united the global community of observers in a single act of listening, a rare moment when humanity gazes outward not for conquest, but for understanding. In December, Swan R2 stabilized beyond the orbit of Saturn, holding position as if waiting. The electromagnetic pulses softened, spreading across multiple frequencies as though diffusing a message through the fabric of space. The deep space network continued to receive faint signals at intervals of exactly 22 hours, a slower, deeper pattern, perhaps a transition from high-energy transmission to a passive monitoring phase. To some, it felt as though the object had completed its purpose for now, entering a state of dormancy. To others, it was preparing for the next stage, the beginning of a dialogue whose first word had only just been spoken. Meanwhile, 3i Atlas reappeared, smaller, dimmer, yet following a path that intersected precisely with Swan R2's current coordinates. The two objects seemed drawn together by invisible geometry. When their trajectories aligned, instruments recorded a subtle increase in radio flux between them, a bridge of communication, invisible to the naked eye but resonant in the data. It was as if they were exchanging information, synchronizing, perhaps recalibrating for a shared purpose. Then, slowly, Atlas began to fade, its energy dissipating into the surrounding plasma until it was gone. In its place remained Swan R2, shining alone, its light steady and calm. If Atlas was indeed the scout and Swan R2 the main vessel, then the cycle may now be complete. One explores, the other observes. One heralds, the other endures. Perhaps the smaller object transmitted its final data to the larger, a passing of memory before dissolving into the solar wind. And now, with that exchange finished, Swan R2 waits, a sentinel anchored to the rhythms of a distant intelligence. What happens next, no one can predict. Some theorists believe that in the next solar cycle, when the sun's magnetic poles flip, the object will activate again, using the changing field to refuel or transmit. Others argue that it will remain dormant for millennia, circling the sun in perfect silence until the next return. But whether it acts or sleeps, its very presence has already changed us. Humanity has seen something that cannot be unseen. Evidence that the universe may contain intention, that across incomprehensible distances, minds other than ours might still shape matter into meaning. When future generations look back at this moment, they may call it the true beginning of the interstellar era. Not because we traveled to the stars, but because the stars reached back. Swan R2 has become more than an object. It is a symbol, a mirror reflecting both our curiosity and our humility. It reminds us that even in a universe filled with silence, there are patterns that speak louder than words. As the object recedes into the darkness beyond Saturn, it carries with it the light of our attention, the weight of our questions, and the fragile hope that perhaps we are not alone. Somewhere in its perfect elliptical path, an ancient machine glides on, steady, unbroken, faithful to its design. It will return in 22,554 years, long after our civilizations have transformed, perhaps vanished, or evolved beyond recognition. But when it comes again, the descendants of those who now study it may still be watching. And maybe, as that pale blue light glimmers once more at the edge of Neptune's orbit, another voice, human or otherwise, will whisper back through the dark. Because the universe, vast and indifferent though it may seem, has a memory longer than time. And once something chooses to shine within it, that light is never truly lost. Swan R2 is the proof. It is the message. It is the enduring pulse of a cosmos that remembers its own creation and waits, patiently, for its children to learn to answer.